Hi everyone, welcome to this video. We will explore the concept of kinematic, specifically about distance, displacement, speed, velocity, and acceleration in AS and A-level physics. My name is Toni Hidayat, and I will be guiding you through this topic, all aligned with Topic 2, Subtopic 2.1 of the Cambridge syllabus. Let's get started. The first learning objective is define and use distance, displacement, speed, velocity, and acceleration. In this section, we will define and distinguish between distance and displacement. Consider a boy cycling from point A to point B and then to point C. Distance is the length of the path taken by an object. So the distance is the total length of the path traveled by the boy without considering direction. Therefore, the distance of the boy is 7 meters. However, displacement is the change in position of an object. So, it is the straight line from the starting point A to the final position C, considering the direction. Therefore, the displacement of the boy is 5 meters. Distance is a scalar quantity, meaning it only has magnitude, while displacement is a vector quantity, having both magnitude and direction. Now, let's define speed and velocity using the same example. Suppose the boy took 10 seconds to cycle from A to B and then to C. Speed is the total distance traveled divided by the time taken. It's a scalar quantity, so it only has magnitude, and the speed of the boy is 0.7 meters per second. Velocity, on the other hand, is the displacement divided by the time taken, making it a vector quantity. Velocity not only tells us how fast the boy is moving, but also in which direction. So the velocity of the boy is 0.5 meters per second. Acceleration is our next concept. Imagine a car that starts from rest and begins to accelerate. Acceleration is defined as the rate of change of velocity with respect to time. It's a vector quantity, indicating both how quickly the speed changes and in what direction. The formula to find acceleration is acceleration equals to change in velocity over time. And then acceleration equals to final velocity minus initial velocity over time. Or in symbol A equal Vf minus Vi over t. It is important to note that in free fall, the acceleration due to gravity from Earth is approximately 9.81 meters per second square. The second learning objective is use graphical methods to represent distance, displacement, speed, velocity, and acceleration. Let's look at displacement time graph below. This is the example of displacement time graph. Here we have two lines. The blue one is going up. It means that the object is moving to the right, as well as for the orange one is going up. But the difference is, for the blue one, as the time increase, the displacement also increase. It shows that the object is accelerating to the right. However, for the orange one, we may conclude that it's going to the right but decelerating. Another example is like this. It's different from the previous one. Now the object is moving to the left, as you see, because the displacement starting from around 35. After 5 seconds, for the blue one is just only around 1 meter. And then for the orange one is just around 7 meters. So it shows that the object is going to the left. What's the difference between the blue and the orange one? For the blue one here, the object is going to the left, decelerating. Meanwhile, for the orange one, it's going to the left with acceleration. Because why? Because for the orange one here, the decreasing of the displacement is more significant as the time goes. Next, we will still have displacement time graph. Yeah. Here we have 4 possibilities for displacement time graph. Let's start by the gray one. The value of the displacement here is 10 all the time. What does it mean? It means the object stay at rest at 10 meter at the right side. And then the opposite to the gray one, for the yellow one here, the displacement value is -5 all the time. It means that the object is stay at rest at 5 meter at the left side at rest because the position doesn't change. And then for the blue one here, the displacement is increasing from around -7 to +12, around +12. It shows that the object is moving to the right. And then because the line is straight line, so we may conclude the velocity is constant. And then for the orange one here, it's moving to the left because the displacement value decreased from 15 to -10. And then because the line is straight line, so the velocity is constant. Next is velocity time graph. These two graphs have the same lines, but we have to interpret them differently, as you see here. And then let's start again by the gray one. For the velocity time graph, it means for the gray one here, the velocity is constant at 10 all the time. And it's positive. Because it's positive, it means the objects move to the right at constant speed of 10 meters per second. For the yellow one, since the value is -5, it's negative. It means that the object is moving to the left with constant speed of 5 meters per second. And then for the blue one here, the velocity is increasing from -10 to around +12. Okay, so let's interpret from the time equals to 0 second to 2 seconds. Because here initially is -10, so it means the object is moving to the left. And then around 1 second later, now the velocity is just around -4. It means still going to the left, but then the value is lower. It shows that for the first 2 seconds, for the blue one, the object is moving to the left with deceleration. After 2 seconds, what happened to the object? Now the velocity is positive. It shows that the object is moving to the right, and then the value increasing from 0 to around 12. So after 2 seconds, the object is moving to the right with acceleration. What about the orange one here? For the orange one, before the time equals to 3 seconds, the velocity is positive. It means the object is moving to the right. But the value is decreasing from -15 to 0. It means from 0 to 3 seconds, the object is moving to the right with deceleration. After 3 seconds, it will be the opposite because now the velocity is negative, so it means the object is moving to the left with the velocity increasing. Yeah, as you see here, because initially 0 and then 5 seconds, and then 5 meters per second, and then 10 meters per second. The negative is just show us the direction. Let's now discuss acceleration graphs. Acceleration is plotted as the rate of change of velocity. A straight line on this graph indicates constant acceleration. So here, for the blue one, the value of the acceleration is +10. It means for this object, the acceleration is +10 meters per second square. It means that the object is accelerated. Meanwhile, for this graph, it shows that the object has the acceleration of -4 meters per second square. It means that the object is decelerated with this value. The third learning objective is determine displacement from the area under a velocity time graph. To determine displacement, we look at the area under a velocity time graph. For example, if a graph shows a constant velocity over time, the displacement is represented by the area of the rectangle under the curve. This area gives us the magnitude of the displacement over the given time interval. As the example, if you want to know what's the displacement from 0 second to 25 second here, because the shape of the area between the graph line and the x-axis is a trapezoid, so we may use the formula to find the area of the trapezoid, which is half times height times a plus b. So half times the height is 20 from this point to this point, and then the a is 10 from this point to this point, and then the b is 25 from this point to this point. So after we calculate, we got 350 meter. So it's mean for the first 25 seconds, the object is moved for 350 meter. And then for the rest of the time here, the graph shows us that the shape we have is a triangle. The area between the graph line and the x-axis is a triangle. So we use the triangle equation to find the area. Half times base times height. Half times the base is 20, from 25 to 45 it's 20, and then the height is negative 15, so we have to include the negative here, and then we calculate, and then we get negative 150 meter. And then to determine the distance, since distance is a scalar quantity, so we don't consider the direction, so we only calculate the total length covered by the object when it moves. So 350 plus 150 equals to 500 meter. For the displacement, since it's a vector quantity, so we have to consider the direction, because the object is actually moving to the right at the first 25 seconds and then moving to the left for the rest of the time. So the displacement will be 350 minus 150 equals to 200 meter. The fourth learning objective is determine velocity using the gradient of a displacement time graph. The gradient or slope of this graph at any point represent the velocity at that moment. The velocity can be determined by finding the gradient of the graph. A steeper slope indicates higher velocity, while a flat line indicates zero velocity. As the example here, before we start for the example, here is the formula to find the velocity. Basically, this formula is coming from the gradient formula. So let's say we are going to find the velocity from time equals to 0 to time equals to 4 seconds. So the final position will be 8 here, and then the initial position is 0. So 8 minus 0. And then for the time will be 4 minus 0. And then we calculate, we get 2 meter per second. It means the object for the first 4 seconds, the velocity is positive 2 meter per second. So the object is moving to the right. And then for another example is what is velocity from 10 seconds to 14 seconds. So we use the same formula. Yeah, final position is at negative 4. So we put negative 4, and then the initial position is at 0 here, at 0. And then the time is 14 minus 10. We calculate, we get minus 1 meter per second. It means that the object is moving to the left, since the velocity value is negative here. And as you see, that the position change from 0 to negative 4 is to the left, yeah, because it's more negative. Finally, the fifth learning objective is determine acceleration using the gradient of a velocity time graph. We will determine acceleration using the gradient of a velocity time graph. Just like before, the gradient here represents acceleration. A steeper gradient shows a higher acceleration, while a flat line suggests constant velocity with no acceleration. Yeah, so before the example, once again, so this is the formula to find the acceleration. It's derived from the gradient. So acceleration equals to the change in velocity over time taken. So let's say we are going to find what is the acceleration when the time equals to 0 until when the time equals to 10 seconds. So from here to here. The final velocity will be 10, and then the initial velocity will be 0. So 20, yeah, not 10. 20 minus 0. And then for the time will be 10 minus 0. And then we calculate, we got 2 meter per second square. It means that the object is accelerating because the value of the acceleration here is positive. Another example is, what is the acceleration from the time 20 here to 25 here? The final velocity here is 0, and then the initial velocity is here 20. So for the change in velocity will be 0 minus 20, and the time will be 25 minus 20. We calculate and then we get minus 4 meter per second square. The value of this acceleration is negative. It shows that it's actually deceleration. So the object is slowing down with this acceleration. That concludes our discussion on distance, displacement, speed, velocity, and acceleration in AS level physics. If you find this video helpful, please give it a thumbs up and subscribe to our channel for more physics content. Also, remember to follow us on Instagram @pengajar fisika for more updates and learning resources. Thanks for watching, and I will see you in the next video.